Okay, Algebra lesson 10.2 is over simplifying radicals. So a radical expression is just something that has this little square root symbol in it. And actually this square root symbol has a name. It's called a radicand. So this is 3 and then the radicand, inside the radicand is a 5. So this is just called a radical expression. So 3 root 5 is 3 times the square root. See how it's squished together and there's no symbol in between? That means they're squished together with a multiply and the square root of 5. So if I wanted to know what 3 times the square root of 5 is, I would take my calculator and I would do 3 times the square root of 5, and it's some irrational crazy number. So a lot of times rather than rounding, you would just leave it 3 root 5. So these are simplified. 3 root 5 is simplified. 9 times the square root of x is simplified. You can have a radical in the numerator. You cannot have one in the denominator. So this is also simplified. These are examples of radicals that are not simplified. The reason that this is not simplified, but this one is because we can actually pull out a number. You can square root, maybe you can't square root 12. I'll show you. You can't square root 12, but you can square root a number that is inside of 12. So if you can think of 2 numbers that you can multiply that would be 12. So right off the bat, I can think of 4 and 3. And guess what? We can take the square root of 4. So you can't take the square root of 3, but you can take the square root of 4. So what is the square root of 4? It's 2. So if you can take just that 2 and pull it out, so the square root of 4 is 2, you would pull that 2 out, and whatever's outside here gets multiplied by whatever you're pulling out. So if we pull out a 2, it gets multiplied by the 3. So outside the radical would now be a 6. And who did we leave inside the radical? We used that one. We left a 3. So actually, 3 root 12 is not simplified because it would have to be changed to 6 root 3. So, and that's exactly actually what we're learning today. You also can't have the square root of a fraction. It changes to something like this, which changes to something else, which we're not going to worry about today. But I do want you to see that you can't have a square root, a radical in the denominator. You can have one in the numerator, but you can't have one in the denominator. So for today, all we're going to work on is this part of how I told you to simplify, kind of like what we did here. So let's skip down to, well, we can look at their example. For 48 is the same thing as 16 times 3. So if you divide 48 by 16, it's 3. So 48 is the same thing as 16 times 3, but 16 has a square root. It's 4. So when you pull out the square root, it comes out as a 4 because the square root of 16 is 4. And who did we have to leave inside? We had to leave this 3. So the square root of 48 is the same thing as the square root of 16 times the square root of 3, but this one has a square root, so it pops out, that guy goes away, and just becomes 4, but you still have the square root of 3 here. So let's try a few of these. The square root of 160, let's think of what 2 numbers multiply to be 160. And by the way, one of them has to be a perfect square. You can't just say, oh, well, it's 8 and 10. Oh, well, that would be 80 anyway. 16 and 10. Oh, actually, that is it, right? Because 16 is this perfect square. Sorry, I gave that one to you this time. We'll work on the next one. 16 times 10 is 160, right? But this one has a perfect square. It is 4 times 4. So when you take the square root of 16 and pop it out front, it is going to be 4. And therefore we've used that. Who gets to stay inside the radical? 10. Okay, sorry. I'll not try to give away the answer for the next one. What about 300? So square root of 300, let's think about what 2 numbers we can multiply that would equal 300, but one of them has to be a perfect square. And you can't just say, here's what I was trying to say before, you can't just say 30 and 10. You Can't say, oh, 30 and 10, because yes, even though that does equal 300, you can't square root 30 and you can't square root 10. So you can't just use any numbers. You have to choose numbers that one of them is a perfect square. I had a student one year who, as soon as he got his paper, he started writing across the top what the perfect squares are. So it'd be like 1 times 1, which is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. I'm going to stop soon, I promise. 9 times 9 is 81. 10 times 10 is 100. Let's go to, I think 11 is 121, and 12 is 144. Okay, so they keep going, but I had a student who did this, and he wrote all of the numbers that were perfect squares at the top of his paper, and that just helped because now we're looking for what times what is 300, and we have to be using one of these numbers. So right away, I see 100, and I know that 100 times 3 is 300. So let's go 100 times 3, and the square root of 100 pops out as 10 because it's 10 times 10, that's 100. So it pops out as 10, and who gets to stay inside the radical? The 3. Okay, let's try 162. So what two numbers can we multiply to get 162, but one of them has to be a perfect square? So let's think about this. 162, I'm thinking that 81 times 2. Is 81 doubled? 162, I believe it is. So 81 times 2, let's just check, is 162, yeah. So 81 and 2. So the square root of 81 is 9. It's the same thing as 9 times 9 is 81. So when it pops out, there's only one of them because the square root of 81 is 9. And the square root of 2 has to stay inside the radicand. So 9 root 2. All right, what about 44? So what two numbers multiply to be 44? I think just maybe 4 times 11. Is 4 times 11 44? 4 times 11. So we're going to do 4 times 11, and the 4 is going to pop out as a 2 because the square root of 4 is 2, but the 11 has to stay inside. Okay, 2 root 11. So go ahead and push pause, and I want you to try to find what the simplified radical form of the square root of 72 is. All right, if you're not quite sure, I will try to come up with this one with you. The square root of 72. What two perfect squares, not two perfect squares, but what at least one perfect square? Is it 36? Is 36 times 2 maybe? Maybe 72. Okay, so it's 36 times 2. And you may have to just play with these numbers and just see. I mean, hopefully everyone has a calculator you can use. So the square root of 36 is 6, so 6 will pop out of there, and 2 will stay inside. All right, now we're going to jump into some numbers that are the square root and some variables. So I want to make sure you make sense of the 54 first. So we're still looking for two numbers that when multiplied equal 54, and one of them has to be a perfect square. So let's think through that first and pretend there is no n to the 7th for right now. Let's think about what multiplies to get 54. So 54, 9, right? 9 times something is 54. 54 divided by 9 is 6. Yes, that works. So let's do 9 times 6. So the square root of 54, we're going to do 9 times 6. And then here's what I want you to know about these n's. Let's just go ahead and expand the notation. Let's just put 7 n's. So n times n, that's 4, 5, 6, 7. Okay. So the reason I'm writing them all out for now is because I want you to see what happens. The 9, in fact, you know what? Let me write this one more time and let me expand the 9. The 9 is 3 times 3, isn't it? Because when we pull out the square root of 9, it's going to be 3 because 3 times 3 equals 9. Times 6 times n 2, 3, 4, 5, 6, 7. Okay, and the only reason I even did this part is because I want you to see it's the same thing as what we're going to do with the n's. You can kind of pull out partners. So when you pull out partners, they only pop out as one of that number. So 9's square root is 3. But it was 2 of them under the square root, but because the square root means a number times itself, when you pull it out, it's only one of them. So that same rule applies with the n's. So we have a partner group here, we have one here, and we have one here. So each of these partners only comes out as 1. So 1 once, twice, 3 times. So there's actually 3 partner groups. So it's going to be n to the third. Okay, or you could think of it as n squared. And we've talked about this before. If you have something squared and you square root it, those cancel each other out. So if there's 2 of them and you're square rooting them, it cancels it out and it's only just the n itself. So we've talked about that before too. So you can think of it as partners, or you can think of it as anything of 2 and you square root it, comes out as just 1, as just the n itself. So here's what we have done. We pulled out the square root of 9, which is 3. We pulled out 3 sets of n's, which is why it's n to the third. Now, who does it leave inside? It leaves the 6 and a lonely n. So those are going to stay inside. So our final answer is 3n cubed times the square root of 6n. Remember, you can't pull that n out because it has to come out square. Like there has to be 2 of them before you can pull 1 out. Okay, that was really tricky. Let's practice a few more of those. Okay, in this particular case, there's already something pulled out. There's already something outside. There wasn't here. But if there was, anything on the outside, when you pull something else out, gets multiplied. So you're squishing it all together. So if there already was something else outside here, we would have multiplied it. So whatever we pull out of the 80m to the 9th is going to get multiplied by our negative 1m, or just our negative m. So negative m is going to stay out here for now. We're kind of going to ignore it as we work on this 80. So 80 is what 2 numbers multiplied, and one of them needs to be a perfect square. I think 80 divides by 16. This might be a guess. 80, and again, you're just going to have to play with these and see. Oh, it does. Okay, 16 times 5. So 80 is 16 and 5, and that was just a lucky guess. You're just going to have to keep playing with numbers until you see. So it is 16 times 5. That's what 80 is. And then there are 9 m's. I'll go ahead and write it out one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I know they should have continued, but I'm going to get into the other space. So we can pull the square root of 16 out as a 4. The 4 is going to get multiplied by negative m. So it's going to be negative 4m. Okay, I don't want to forget what I've already used. 5 is going to have to stay inside the radical. How many partner groups can we pull out? We've got 1, 2, 3, 4. So we're pulling out 4 m's, and we already had one here. So that is going to make it 5 m's. Now, who do we have still inside the radical? We have 5, and we have this lonely m that we can't pull out because it doesn't have a partner. Okay. So that was a little tricky. I hope it made sense, but let's keep going to practice a few more. Square root of 16b to the 5th. So 16 is a square root itself. You don't have to multiply it by anything. That's just going to pop out as a 4. But we've got 5 b's on the inside. We've got 1, 2, 3, 4, 5. So remember, every 2 can come out as 1. So it's going to be b to the 1, 2, and our lonely little b is the only one that's going to have to stay inside. All right, I have a couple of you tries. This is our last thing for today. So you try these 2 and pause the video and see if you get the same thing that I get. All right, if you weren't quite ready to do it on your own, or if you're just checking, here's what I would do. I have the negative 21. What numbers, when multiplied, equal 27? I think 9 times 3 is 27. 9 times 3? So I'm going to have 9 times 3, and then I have 9 x's. Hopefully you know that every partner group that we can pull out means divide by 2. So what I'm going to do first is I'm going to pull out the 9's square root, which is 3. When you pull out this 3, the negative 21 that's out here is going to get multiplied by it. This little squishing them together means multiply. So negative 21 times 3 is negative 63. Okay, done with that. The 3 is going to be lonely and going to have to stay inside. Partner groups of x's I can pull out is going to be 4, because I know that 8 divided by 2 is 4, but there's going to be 1 left over inside here. So I'm going to pull out 4 x's, and I'm going to leave 1 inside, along with my 3 that was also still inside the radical symbol. All right, and then the very last one, we have this 3 out here that's going to get multiplied by anything else that we pull out. The 18 is going to be another 9 times 2, and we've got A and A. All right, so the 9 square root is a 3, and when it pops out, it's going to get multiplied by the 3 that's already there. So we've got 9 on the outside, and then I've got a partner group of A's that can also be pulled out as 1A. So the only thing that's going to stay inside is the 2.